I am doing problem number 4 from the 2022 BC Calculus AP exam. This is a table problem, and in this problem, an ice sculpture melts in such a way that it can be modeled as a cone that maintains a conical shape as it decreases in size. The radius of the base of the cone is given by twice differentiable function r, where r of t is measured in centimeters and t is in days. The table above gives selected values of r prime of t, the rate of change over the time interval 0 is less than or equal to t is less than or equal to 12. For part A, we need to approximate r prime prime of 8.5 using the average rate of change of r over the interval 7 is less than or equal to t is less than or equal to 10. Show the computations that lead to your answer and indicate units of measure. So for this problem, we are going to know that r prime prime of 8.5 is approximately r prime of 10 minus r prime of 7 over 10 minus 7, which equals negative 3.8 minus negative 4.4 over 3 equals 0.6 over 3 equals 0.2 or 1/5. For part B, we have to find, is there a time 0 is less than or equal to t is less than or equal to 3 for which r prime of t equals 6. So r prime of 3 equals negative 5.0, which is greater than negative 6, which is greater than negative 6.1, which equals r prime of 0. Therefore, by the IV team, there exists a time t t 0 less than or equal to t is less than or equal to 3 such that r prime of t equals negative 6.0. For part C, we need to do a right-hand Riemann sum with the 4 subintegrals integrated in the table to approximate the value of the integral from 0 to 12 r prime of t. So, the integral from 0 to 12 r prime of t is approximately the step here is 3. The step here is 4. The step here is 3. The step here is 2. So it is approximately 3 times negative 5.0 plus 4 times negative 4.4 plus 3 times negative 3.8 plus 2 times negative 3.5, which is equal to 51 centimeters. And units for the first problem, 0.2 centimeters per day squared. For part D, the height of a cone decreases at a rate of 2 centimeters per day. At time t equals 3, the radius is 100 centimeters and the height is 50 centimeters. Find the rate of change of the volume of the cone with respect to time in cubic centimeters per day at time t equals 3. For this problem, we have to use implicit differentiation on the volume of cone. So V equals 1/3 pi r squared h. 2 dv over dt equals 1/3 pi 2/3 pi r h dr over dt plus 1/3 pi r squared dh over dt. dv over dt equals 2/3 pi times the radius, which is 100, times the height, which is 50, times the change in radius, which is -5, plus 1/3 pi times the radius squared times the change in height, which comes out to dv over dt equals -70,000 pi over 3 centimeters cubed per day. So the answer for A is 0.2 or 1/5 centimeters per day. The answer for B is -6. The answer for C is 51 centimeters. And the answer for D is -70,000 pi over 3 centimeters per day.